All right. Welcome back, everyone, for another deep dive where we like to kind of go
Yeah.
beyond the headlines and into something pretty interesting. And today we are going to be tackling quantum computing.
Right.
Um, I have been looking forward to this one
It's going to be a good one.
for a while. Our source material today is
Mm.
uh, th this document. It's titled Pasted Text.
Mm-hmm.
I don't know who titled it that, but
Uh-uh.
yeah, we'll go with it.
Sounds.
And it seems to be like a primer on quantum computing.
It
So
is.
we're going to be your guides
Oh.
today as we unpack, the science, and the possibilities, the implications of a world powered by quantum computers.
Yeah, and what's really fascinating about this is that we're not just talking about, faster computers. We're talking about a completely fundamental shift in how we process information.
Yeah. So
Yeah.
let's start with that.
Go.
What is it about quantum computing
Yeah.
that makes it so different from the computers we use every day?
Well, it really comes down to harnessing the strangeness of quantum mechanics. Classical computers, the ones that we're all familiar with, use bits,
Right.
which you can think of as like tiny switches that are either on or off, representing 1 or 0.
Yeah.
Quantum computers use these things called qubits, which can simultaneously be both 0 and 1 at the same time. It's mind-bending.
That's
It's like a
right.
coin spinning in the air, existing in this weird state called superposition, until it finally lands and we get a result.
Okay, so I think I'm starting to get it.
Okay.
So one qubit can basically multitask like crazy.
Exactly.
But how does that translate
Yeah.
into actual problem solving? Is it like a team effort or something?
Well, it is a team effort.
Yeah.
So these qubits are linked together through this phenomenon called entanglement,
Oh, yeah, entanglement.
which allows them to influence each other instantly, regardless of distance. So they're working in this kind of quantum harmony, if you will, to explore many possibilities simultaneously. You can almost think about it like a team of chefs all working on different parts, a complex dish at the same time, constantly coordinating their efforts.
I love that analogy.
Yeah.
All right, so now I'm starting to see why people get so excited about this.
Right.
But, give me like a concrete example
Yeah.
of how this quantum teamwork actually solves a
Sure.
real world problem.
Imagine you're a pharmaceutical company and you're trying to develop a new drug.
All right.
A critical step in that process is to understand how these proteins fold into these specific shapes, and those shapes determine their function. Now, to simulate that process on a classical computer can take years,
Oh, wow.
but a quantum computer can theoretically do it in a fraction of the time, thanks to the way these entangled qubits can explore multiple folding pathways at the same time. So this could completely revolutionize drug discovery, allowing us to design highly targeted therapies much faster.
So instead of taking, years to develop a life-saving drug,
Yeah.
it could take weeks or even days.
Yeah, potentially.
That's incredible.
Mm.
But our source material also mentions something called quantum interference.
Right.
How does that fit into the picture?
Quantum interference is kind of like the secret weapon that allows quantum computers to sift through all those possibilities generated by superposition and entanglement,
Right.
and then hone in on the right answer.
So it kind of sorts through
Right.
all the riffraff and
Yes,
picks the right.
exactly. Think of it this way. You're trying to find the best route for delivering packages across a really busy city,
Okay.
thousands of stops. Quantum interference helps the quantum computer amplify the signals from the most efficient routes while canceling out all the noise from the less optimal ones, leading to a much faster and more accurate solution.
So it's like a super powered GPS for problem solving.
Precisely. And this is where things get really interesting, because this ability to tackle such complex problems opens up a whole new realm of possibilities. Quantum computers are particularly well suited for tasks like optimization, cryptography, and simulating quantum systems.
Okay, so let's break those down a little
Yeah.
bit. You already mentioned how quantum computers could speed up drug discovery.
Yeah.
Which falls under simulating quantum systems.
Mhm.
But what are some other applications in that area?
Well, the potential is vast. I mean, imagine designing new materials with unprecedented properties, like superconductors that operate at room temperature, revolutionizing energy transmission,
Wow.
or developing these ultra-precise climate models that can help us understand and address climate change with much greater accuracy. The ability to simulate the behavior of molecules and atoms at a fundamental level
Cool.
could transform countless fields.
Like it's unlocking a whole new level of understanding about the universe itself. What about those other areas you mentioned, optimization and cryptography? What makes them so well suited for quantum computing?
Optimization is all about finding the best solution among a vast number of possibilities.
Okay.
We already talked about the package delivery example, but this applies to tons of scenarios, from optimizing traffic flow in megacities to streamlining global supply chains. Quantum computers can tackle these problems with unparalleled efficiency. And then there's cryptography, which is essentially the art of creating and breaking codes.
Yeah, that's the area where I've heard the most buzz, especially about, concerns about quantum computers cracking the codes that protect our online data.
Right, that's a valid concern. Quantum computers could potentially break the widely used encryption algorithms that protect our financial transactions, our personal information, and national security secrets. But this challenge also fuels innovation. We have this thing called quantum cryptography, which utilizes the principles of quantum mechanics to create theoretically unbreakable codes. So any attempt to intercept those codes would instantly alter their state, alerting both the sender and the receiver to a breach.
So it's like a self-destructing message. That's super cool. So it guarantees secure communication.
It's this fascinating race between code makers and code breakers, with huge implications for cybersecurity in the quantum age. But the key takeaway here is that quantum computing isn't just about replacing our laptops or, making things a little bit faster. It's about tackling problems that are simply beyond the reach of classical computers.
It's a whole new paradigm of computing.
Yeah.
But where are we actually at in terms of building and using
That's a great question.
these quantum computers?
It's still very early days,
Okay.
but the progress is very rapid. Companies like IBM, Google Rigetti, and IonQ are building increasingly sophisticated quantum processors. In fact, Google's demonstration of something called quantum supremacy
Oh, yeah, I've heard of that.
a few years ago marked a really major milestone. They essentially built a quantum computer that solved a specific problem in just 200 seconds.
Whoa.
That would have taken the world's most powerful supercomputer 10,000 years to solve.
That's unbelievable.
And that problem involved sampling the output of a random quantum circuit. But it essentially proved that quantum computers could outperform classical computers in certain, albeit very specific tasks.
Yeah, I've heard that it's not really a, end-all, be-all type of test,
No.
but it certainly shows the power.
It's a very narrow test,
Yeah.
but it shows the potential.
So it seems like the race is on to build bigger and better quantum computers.
It is.
But surely there must be challenges along the way.
Absolutely.
What are some of those?
One of the biggest hurdles is this thing called decoherence.
Decoherence.
Qubits are extremely sensitive to their environment.
Right.
Even the slightest vibration or temperature change can disrupt their delicate quantum states, leading to errors in calculations. It's almost like trying to build a house of cards on a vibrating table.
Yeah, so maintaining the stability of these qubits is crucial.
Absolutely essential. And that leads to another challenge, which is error correction. Developing robust methods to detect and correct errors in quantum computations is paramount. And then, of course, we need to figure out how to scale up these systems. Building larger and more stable quantum computers requires overcoming some significant engineering hurdles.
So it seems like there's still a long way to go before quantum computers become as common as our smartphones.
Right.
But even at this early stage, the potential impact on society is immense.
It is.
What are some of the key things we should be thinking about?
Well, quantum computing has the potential to reshape entire industries, economies, and even the geopolitical landscape. The development of new drugs and materials could transform healthcare and manufacturing. And then this ability to break existing encryption poses these significant cybersecurity threats. But it also drives the development of new ultra-secure communication methods. And then you have this race to achieve quantum supremacy, which is already fueling this global competition among nations and tech giants. And then on top of all of that, you have these ethical considerations.
Yeah, what kind of ethical concerns come into play?
Well, imagine a world where personalized medicine is tailored to your genetic makeup, but that information could be used to discriminate against you.
Oh, wow. Yeah, that's pretty scary.
Or a world where quantum computers could design autonomous weapons systems with unprecedented capabilities, raising serious questions about human control and accountability. As this technology evolves, It's really crucial to have these open discussions about its potential benefits and risks, and to develop ethical guidelines for its development and deployment.
It seems like we're on the cusp of a technological revolution that could be as profound as the invention of the internet.
It really could be.
It's exciting and a bit daunting. At the same time,
It is.
It really makes you wonder, what will the world look like in 20 or 30 years when quantum computers become more commonplace? You know, what new industries will emerge? What ethical dilemmas will we face?
These are questions we can't answer definitively, but they're questions that we absolutely must grapple with. As we delve deeper into this quantum realm, we're not just exploring new technologies, we're exploring new ways of thinking about the universe and our place within it.
That's a perfect note to end on. Thanks for joining us on this deep dive into the fascinating world of quantum computing. It's a field that's constantly evolving, so stay curious, keep learning, and who knows what incredible breakthroughs the future holds.
Yeah, who knows?
All right, everyone, thanks for listening, and we'll see you next time.
See you later.